Hey guys, just a quick video to show you where I'm at what stage of the game I'm at with my project. I set up a couple racks. The bottom rack is of lights is wired parallel, and the top rack is wired series. I just kind of wanted to play around a little bit with see what kind of charging I was getting, how it compared between the two different types of loads. I'm noticing that self-oscillation seems to have a lot to do with the impedance difference between the primary and the secondary battery banks. For whatever reason, I'm noticing that it has an effect on whether it'll oscillate. I tried hooking up that resistance-based self-oscillating device that Pariah had shown on the forums, but I don't know. I had a few mishaps. Actually, this is it here. Well, I did end up getting a coil kind of hot. I was checking the impedance across the resistors to make sure I had them 18, 20, and 18, 10. Oh, I can't even remember. Anyway, it's been a long day, but I'd crafted up one of these little batteries. It's actually a 6-volt lithium battery, two of them stuck together, and I turned them into little power packs for testing out short durations. And I guess they're not meant to be charged, but they charge really well on this. So I've got some powerful little lithium batteries. And what I've got right now is one hooked up here, and it's hooked up to the amp meter. I'll be able to connect that lead and this to get a reading while it runs the wheel in just a moment. I've got the amps there, and over here I've got the volts, which aren't showing anything properly yet because it's not connected. Power supply is off and not connected. Over here I've got some really beat up batteries. I'm going to be picking up some better test batteries, as I was explaining. These batteries, even though they're running at a lower voltage right now, still perform and outperform regular batteries of that amp hour that are used to positive ion flow, and I can't explain it, but it really does. They do really outperform regular batteries. Here's the coil, and I've got the positive, the negative lead coming up all the way up here, connected to that black one, and that black line is taking it over to the collector on this circuit. So this circuit is looking after firing the ignition coil as opposed to the power coil in this bifiller coil. So this coil and that coil are running. And the reason I'm doing it this way is I think because I've wired them in a parallel circuit, 2 coils is about all you'd want to run in a parallel circuit. And Ren had pointed out how you can set up a slave and a master situation that might be a little bit better than what I was going for here. 2 coils, though, however, hooked up with an ignition coil like this, will run in a parallel circuit to create some even lighting as the wheel pulses. So I'd stripped off a lot of that fiberglass crap and everything else, just used the resin and the hardener to bond them on there. Seems to be working good. Actually, the resin and the hardener actually seems to have turned the hot melt glue that I used a little bit harder. So I've got a freer spinning wheel now, which is nice. Since I'm only going to be relying on 2 coils to actually drive the wheel, I really do want the wheel to be as light as possible. But anyway, without wasting any more time, I'll just quickly set the camera down here. I'm going to hook this up. It started to self-oscillate, but it stopped. Okay, it's hooked up. And just so that you know that this is indeed what's running it. There we go. Okay, and these voltages are dropping pretty fast on this battery. I'm wondering where it's going to stop. And it will if I stop it here. Self-oscillate. These are 150 watt equivalent bulbs. They're energy smart. I'll just show a better picture of it. Energy Smart 42 watt bulbs made by General Electric, and I've got 4 of them here. These are wired in parallel right now, and they are producing charging on this bank of battery. However, I will admit this battery here will not last for very long. It's already dropped down below the 12 volt range. But yeah, it's interesting that it will actually run this circuit pretty good. And I'd be afraid to see how long it would go. See, it seems like the lights will run a battery down and stay at a constant brightness in a parallel circuit for a really long time. You know, right to the point of killing the battery completely. I guess that's not a good thing to do, of course, but I do notice that there's really no drop in illumination. But before I really kill this battery, I'll disconnect it. Kind of what I'd like to see. See how quick these volts jump back up. Yeah. What I'd like to see is a small setup with a smaller light with these 2 batteries flip-flopping back and forth, because I think you can just set it to a timer even, and have a small light setup flip-flopping and running a coil. The charge rate with these batteries charging themselves, one on the secondary and one on the primary, is really fast. So, but yeah, that's about it for now. I'm going to be showing a few more things that I'm doing. Not that any of it is anything consequential, but I have found that this coil here was the best suited for running an efficient wheel. As far as getting it to run fast. Anyway, well, thanks for joining me.